continuing on with the Unit 6 Review 2. So I'm solving 2f. So I want to clear the fractions. I want to multiply by 3, the denominator. Don't forget to distribute it to everything. Okay, so it gets multiplied here and there. So we get 3x plus x equals 12. These are on the same side, so I combine like terms. Divide by 4, and x equals 3. Okay. Looking at question number 3, we are going to look at some literal equations. Basically, you have more than one variable. So we've got, this is a, t equals an plus b, and we want to solve for the b variable. So this one's actually pretty easy. So what I'm going to do is I got to get the b by itself. So remember, solving is defined as getting an isolated variable. Okay, so the b is by itself because I subtracted an to both sides. Then that's done. That is solved for b. Okay, looking at b. Okay, and we're solving this one for y. So I got to get that y by itself. So the first thing I'm going to do is I'm going to add this a to both sides. And I cannot combine these because they're not like terms. So I'm just going to write them. That's where a lot of people get themselves in trouble. So this is just like the fractions that we were clearing in the other video. And so what I'm going to do is I'm going to multiply everything by the denominator, which is 3. So I end up as 3 over 3y equals 3a plus 3b, and then y equals 3a plus 3b. And that's C. Okay. And we're going to solve this one for the m value. So those two are being multiplied. If I write two numbers next to each other, or two letters, so I'm just going to divide by a. So we get f over a equals m. And then d, which is very similar to that question. But this time we'll solve for the a. So in this case, I'll divide by m. Get f over m equals a. Alright. So now looking at writing the explicit formula, okay, for geometric sequences. So what I'm going to do is I'm going to take that graph and just take those points. I'm going to make a table out of them. Okay, so how I want to do this is, I want to do this a certain way. I always want to start, so I'm going to say 0, 1, 2, and 3. Okay. So we have our n values and our t of n values. So put the picture underneath here. So it's 1, 6, 2, 18, 354. So that's where I put these in. So there's my 6, my 18, and my 54. Okay. So we ask ourselves, how do I get from this one to this one? And it's times 3 times 3. So I need to find this 0 term. Okay, I got to go backwards. So to go backwards, I need to divide by 3. So my 0 term is t. The formula that I use is t of n equals t of 0 times r to the n. Okay, so this t of 0 is this whole term. Okay, and the r is how I get from this number to this number. So in that case, it's a 3. Okay, and there's my equation. All right, let's look at part B for this one. Set up my table again. N, t of n, 0 term, which I need to figure out. The first term, second term, and the third term. Looking at this one, this was 1, 12, 2, 36. and 108. So this is very similar. This one's also times 3, right? But I use different numbers, so it's going to change the stuff a little bit. So same thing, I'm going to divide to go this way. So this is going to be 4. So the answer to this one is T of n equals 4 times the R value, which comes from these two. And I guess I could just punch that in, sorry. To the end. All right. So now we're going to look at some word problems. So it says there's 21 animals on a farm. They're all sheep and chickens. If the animals have a total of 56 legs, how many types of animals live on the farm? Okay, so we have to define stuff. So we're going to let x equal the number of sheep, aka 4 legs. We're going to let y equal the number of chickens, which is animals with 2 legs. So we have 2 equations. One that does just the number of animals, and one has to do with the legs. So they say there's 21 animals. So if I add them all up, so if I take the number of sheep plus the number of chickens, that's 21 animals. That's just animals, nothing to do with legs. And then we do the leg ones. They tell us there's 56 legs. And that's if you add them up. So if I take the number of sheep and multiply it by 4, and I take the number of chickens and multiply it by 2, that's how many legs there are. So now I need to solve. Okay. I'm going to go ahead and use elimination method. So I'm going to get rid of the y's. I'm going to multiply both sides by -2. So I'm looking at -2x minus 2y equals -42. And then 4x plus 2y equals 56. Those are my opposites. So I'm looking at 2x equals 14. Okay. So x is the number of sheep. So there are 7 sheep. So I'm going to take this equation before I multiply by -2 and find out how many chickens there are, which is going to be 14 here. So it's going to be 7 plus y. Subtract that 7 to both sides. Okay, so there are 7 chickens and 14 sheep. Okay, I got to answer in a sentence. There are 7 chickens and 14 sheep. Okay, and looking at the last one. This is a school is selling tickets to a performance. Okay, on the first day, they sold 3 senior tickets. So I'm going to let x equal the number. Sorry. I'm going to let x equal the price of a senior ticket. And I'm going to let y equal the price of a child's ticket. Okay. So on the first night, they sold 3 senior tickets and 1 child ticket, and they made $38. On the second day, it looks like they took on $52, and they sold 3 senior tickets plus 2 child tickets. Okay, we want to find the price of each. Okay, so this time I'm going to go ahead and get rid of the x's by multiplying by -1. So we're going to end up with -3x minus y. Don't forget to distribute to this second number. -38, and then 3x plus 2y, 52. Those are my opposites, and I get y equals, right? So then I subtract those right there. Okay. And then it'll give us the price for y, which is child's tickets. Okay. So now I'll go back and plug in. So I'm going to plug in. I'll plug in right here. So we're going to say 3x plus 2 times 14 equals 52. And I'm going to find x right now, which will give me the price of a senior ticket. All when I work this out, it's going to say a senior ticket cost, that was the X's, $6, and a child ticket is $14.